So we can continue the session. So we were just in this page looking at the IANA website for different DNS parameters, resource record types. What I wanted to show you quickly right now is root servers, also mentioned by Pio earlier. But did you ever think how many root servers are available in Myanmar? So go to the rootservers.org page. You will find a map that shows the locations of the different root server instances. As mentioned, there are 13 root servers. There are A all the way to m.rootservers.net. If you notice, there's quite a lot more instances of some root servers compared to others. Out of these root servers, mroot is the one that is operated by someone or an organization within our region, and that is the wide project in Japan. So slowly we are trying to increase the locations of the instances of this root server. So hopefully we'll have more potentially in Myanmar as well at some point. But currently, checking the map here, there are 4 root servers in Myanmar. One F root, which is in Yangon, a K root, also in Yangon, and then 2 L root. One is in Mandalay. So 4 root servers altogether. So why do you need a root server, and what are the advantages of having a root server locally in Myanmar? If you remember that the query in the diagram showed by Pure earlier, the query always starts with root. So it's always a positive if you have the root as close to the clients as possible, because that means there is less latency for the overall DNS query, which means a better experience for your users. It also means obviously for different potential attacks at some point to root servers. If you have a local instance, then obviously this is distributed, so there's less prone for this being subjected to lengthy amount of time being unavailable. So we want to have as much redundancy of DNS servers across the region in local economies in multiple locations, so that it can serve with the amount of queries that is required by all, like, how many billion people trying to access the internet. All right, another thing I wanted to show you, we can actually start with this DNS lab, but maybe just very quickly look at some DNS queries. Here I have a DNS server running locally on my machine. It's actually a very simple one. I just run Docker. This is an authoritative DNS running bind 9.18, which is the current stable release. This is probably not going to run. I have to stop it and then remove it first. And then let me run that again. I wanted to run this because it will show the logs like this in the foreground. So you can see a lot of information here. So which version it's running. This one is running bind 9 with this version. And then somewhere down here, some of the features and some of the algorithms that are supported, particularly for encryption, for transaction signature, and for DNSSEC. It does create automatic empty zones. So later on, when we go to the labs, you will see that you will have multiple zones for the domains that your server are going to be authoritative for. So here it's going to create multiple automatic empty zones for reverse DNS, pretty much, basically for address blocks that are not allocated. So it will not do a query going out to the internet. It will just query locally within the machine. And then what you're looking at here is that all your zones have loaded. If this is an authoritative DNS server, then it will mention zones as well that are loaded. But at the moment, it's just localhost. Now, from here, I can do a query. Earlier, we saw dig or drill being used. Dig is a utility that is also installed as part of the bind9 package. So if you needed it, you just install bind utils. So say for example, I do a dig academy.apnic.net. This is actually a query, okay, that queries 192.168.0.1, which is what I have configured in my resolve.conf. So generally, with the HCP, you will get an IP address, you'll get DNS settings, and you will use that DNS settings in resolve.conf, and that's the default that your machine or your client will try to query. Now, if you want to query something, a different DNS server, let's say, for example, since I have it running in my local machine, I can do dig at 127.0.0.1, which is the localhost IP address, or I can simply do dig at localhost for this, and it should do the query on the DNS server that I'm running. So you see the logs, it actually tried a few things here, to do the resolution, and then was able to provide an answer. So here with this query, you will see some flags, okay, that it is asking for query, recursion desired, and then the status is no error, meaning it gave us an answer. And then over here is the answer. I queried for an A record, okay. If you don't specify anything in a dig query, the default is an A record, but you can specify something else. Say, for example, maybe just do apnic.net minus tmx, which will ask for the mail server for apnic.net, and it will give me these three mail servers as part of the answer. Now, what you notice somewhere here is the query time. It's 32 milliseconds. That is the initial query. And if I try to perhaps do this again, it usually is much faster. Now, I'm actually running authoritative DNS here. I'm not sure if it's doing caching at the moment. I haven't configured it. It's just using it by default. But if it is, generally, the query time will be much smaller, even most likely 0 millisecond, because it already has the information in its cache, and it will be available for the duration specified in the TTL. TTL is the time to live. That is the maximum amount of time that the record is available without having to connect and query the authoritative DNS server again. What you notice here, as in the previous question here, you have 3600 is the TTL. Now, when I did a query again, it's lower. It's 3583. And if I do this again, if you notice, again, it's lower because this is a TTL and it's going down. And when it reaches 0, and it will do a query again. But since it hasn't, then it will just give the answer that's already in the cache. So another important thing to note here is the message size received. So it's 144, which is 144 bytes. Can you imagine? It's actually a very small response. The query itself is usually smaller. The response, the DNS response, is a little bit bigger, maybe 2-3 times bigger than the query. But if I do, let's say, for example, plus DNSSEC, we won't be discussing this today, but DNSSEC is for validating records. So if your DNS server is implementing DNSSEC, it will also give you a corresponding signature like this, RRSIG. This is the signature for this A record. And if you notice, the message size obviously has increased compared to, let's say, APNIC.net, which only has 82 bytes in the query. So this is around 3 times, almost 3 times as big as your original query, because you have more information in the response because it's now including the RRSIG. So that is a typical query. I think you can use this if you're doing troubleshooting. Say, for example, as a client, as a user, which DNS server are you using? Is it something that you configured? Like in my example, I have the DNS server running in this exact machine, and I just do a dig at localhost or dig at 127.0.0.1. So that's something that I set up. I have full control over this DNS. I have a tendency to use my own DNS server, especially when I'm traveling, moving to different networks. Then I can just use my own DNS server. Now, the other one is if you use the DNS server provided to you by your service provider, right, your ISP, or whichever network you are connected to. Much like when I showed you the contents of my resolve.conf. This is the name server configured and given to me, and that is the default that I will use if I don't specify or if I don't change the records that is in this file. I can also, of course, use public DNS servers, such as the ones maintained internationally. We call them cloud DNS providers, such as Google DNS, Cloudflare, Quad9, and a lot of others that are available out there. They are running public open resolvers. Now, when you set up a resolver, let's say if you're the administrator and you're providing this service to your clients and to your customers, generally, the idea is to keep this DNS recursive server only available to your clients. You're not supposed to make this available to the public. Obviously, there are public DNS servers, but they also have the resources and the capability to then do more, suppose like monitoring or anything that can or have a potential to abuse the system. They're able to address that easily. But obviously for smaller providers, maybe we don't monitor as much, or we don't have the technology or the resources to address attacks when they happen. So the ideal is to keep your DNS servers only limited to your clients. So you have, say, an ACL or access list that limits only to a number of IP addresses or IP address blocks that can do query on your recursive DNS server. All right, so I wanted to show you quickly, I think this is a public DNS server list. And if you go down a little bit here, there is a list of the economies that they are doing the test. If you go into Myanmar, these are some of the public DNS servers that are available out there. Obviously, you still have the big operators that I've mentioned about. These are some of the biggest public DNS service operators. You have AdGuard, Clean Browsing, Cloudflare, Dynance has been around for quite a long time. You have Google DNS, Newstar, OpenDNS, APNIC, Quad9, Yandex. This is not exactly a complete list, but some of the biggest public DNS providers are listed here. The good thing with these resolvers is that although if you remember earlier, we said that you want your resolver to be as close to your users as possible, and there's a reason for that. It is something to do with latency, so that the responses can come as quickly as possible. It also has to do with bandwidth, so that you're saving bandwidth if the queries are kept local and not going over to the internet. These DNS providers are actually doing pretty well when it comes to latency. If you look at, I think I may have the link in here as well. You have DNS Perf. This link here, if you open it up, will show you information about public DNS servers as well as other things as well. But focusing on public DNS servers here, and shows you the query speed for some of those. So 1111 has the best so far with this test, 9.26 millisecond when you do the query. Obviously, it's not the end all and be all of everything. Latency is good, but you want also stability. You want those DNS servers to be available all the time. So the uptime should be close to 100% whenever possible, and also the quality of the query. So you can look at this list if you are considering using public DNS service for your network or for your clients. So that's a good resource to make. Now, how do you then know if you are operating a public resolver? As I've said, you don't want to be operating public DNS resolver, maybe limit that only to your client. So this is a very good tool to use. There are others out there. This is just the easiest because there is a user interface that you can easily show to your team or show to your clients or to your administrators. It says that if you get open resolver detected, when you do this dig, or maybe just add IP address here and then click test IP, then it will be obviously, it says then you have a problem because you don't want to be running open resolver. So try it out. When you get a chance, open a CLI, do the dig query dig at, what was that one? Let me just copy that one. Dig was short. And let's say, for example, I wanted to try 8888 or maybe here 9999. We know that it is an open resolver. So when I do that query, it will give me open resolver detected, which is what we are expecting. Again, try this out with your own DNS server, the one that you're using on your machines right now, the ones that your ISPs are providing to you, and check whether you're running an open resolver. That's not ideal. That's not the best practice in most cases. So I would encourage you to make changes if you are running an open resolver. Another good resource also linked on the wiki is this Shodan report. Shodan is used for a lot of things in security, but just very quickly related to DNS is looking at anything, any DNS server that is running on port 53. If you see here, it's not that big, but running on port 53 and has recursion enabled. So these are some of the economies. They're quite concentrated in some larger economies. I don't see Myanmar in this list, but it's always good to check, as this obviously the information that is here has a tendency to change. At the moment, there are like almost 2 million, based on this report, open resolvers that it was able to find. So again, it's a bit of a problem. All right, now just very quickly, I suppose we can still touch on the DNS resolvers presentation. I'll make that a quick one so that we can proceed with the next part of the presentation or the lab. But I'm going to just very quickly do a presentation in this one. So hopefully you're already familiar with DNS resolvers at this stage. Our focus, based on this diagram, is this one in the middle, which is kind of like the DNS server between your host or your clients and the rest of the DNS server. You have multiple DNS servers, different hierarchies, of course, following the root DNS hierarchy as such. And then over here is your recursive DNS that does the iterative query starting from the root until it reaches an authoritative name server to get back the answer and send that to the host. So what are the different considerations that you need to think of? This is not an exhaustive list. This is actually based on a presentation that I made in one of the NOGs. But this is a good start. You know, if you're going to operate a DNS resolver and you're offering this to your customers and to your clients, please try to look at these different considerations. The first one being performance. I've shown you latencies of some of the public resolvers. You want to achieve this almost the same if you can. So performance is important in DNS. Latency and query times are like the two important parameters to take into consideration. And there is also a discussion on whether you use a local DNS set up by your admins that is, you know, within your network most of the time, or are you going to rely on a public DNS server? Another one, maybe I'll use my laser pointer. If I can do that. There you go. The next one is features. More and more these days, we are worried about DNS being or providing some filtering or ad blocking features. The reason is because you don't want your clients to be able to obviously open malicious websites. And if there is a way that we can block those from just the DNS part, it means that sites those malicious sites will not be accessible to users. So features like this is getting more and more important. A lot of the public DNS resolvers are also providing such protection, and also DDoS protection as part of this group. So it might be good to look at those options. Now, the other one is security. So secure transport and DNS validation. Now, very quickly, let me touch on some of those. So as we said, DNS latency is crucial. Okay, so when you look at the total query time, it actually is about, let's say this is your host. Before your host can even open a website, and then it loads the website, right? This is very simple access to, let's say, mmnog.net. Your host will do the DNS query first, goes to the recursive DNS. So the total query time is from that point when it sends the initial DNS query to the recursive DNS, plus the time that it takes for your recursive DNS server to get the answer from the authoritative server. Again, it will do a recursive query, right? So it might take longer. Now, if it is in the cache, then that's good. It will be much faster because this part, the time for recursive query, will now be 0. It will mostly just be this RTT between the host and the resolver. But again, both of those parts will have a play, and importantly, in how much time it takes for your host to do the query. That's also one of the reasons why you want the root server to be, again, as close to the users as possible. So DNS latency is crucial. So we've only shown an example of a query using dig earlier. The important part that I wanted to show you here is the query time. So that is 17 milliseconds. That's this part that we are talking about in here, and you want that to be as small as possible. The next one here is an example using drill. Again, for this query, it actually took a lot longer with 107 milliseconds. All right, now what other factors are affecting DNS performance aside from latency and the query time? There's also a couple of things that I wanted to point out that is mentioned in the RFC. One is cache misses. So we said that it's actually going to be faster if the information that you're querying is already in the cache. So if you have 1,000 users, one of them queries for mmnog.net, it goes to the cache for a certain amount of time. And if you have maybe 100 other users, then their query time will be faster because it is in the cache. But what about if it's not in the cache? Again, it's longer. So as much as possible, you want to improve caching. And that is actually discussed more in RFC 2308, so that you can reduce the response time for answering even negative answers. Because even though the response, it's either serve fail or non-existent domain, NX domain, it will still try to do that, query, and it will still take a long time. So trying to improve that. The next one is resiliency of DNS. Again, performance is greatly affected by availability of the DNS service. So you want your DNS to be available to your users. One way of doing that is having 2 or more redundant DNS servers that your users can query. So usually when you look at your resolve.conf, there should be more than one DNS server set in there. Usually 2 local DNS servers. And sometimes this is getting more prevalent. You see 1 or 2 local DNS that is added there. And as a backup, most of them will also add one of the public DNS servers such as Google DNS, Cloudflare, or Quad9 on the list. So you want to make your DNS more resilient as much as possible. There is this RFC 8767 about serving stale data. So again, you also want to make sure that it has a reduced impact on the performance of your DNS, so it doesn't impact negatively on your DNS server. Now, this one is a question I get a lot. Should I use local DNS, cloud DNS? Which one is better? Um, that is always a hard question to answer. That's because that always depends on your location, your needs of yourself or your organization, and the risk level that you're willing to take. If you are managing it yourselves, what are the factors that you need to take into consideration? Availability is a big one because sometimes it's a smaller network. You have only a bunch of people to manage it. So availability is something that, is a big ask, especially if your admins are also in charge of a lot of other things. Most of the time, we notice that there isn't one admin or zone administrator that only focuses on DNS. It's usually a bunch of other system applications that they are in charge of, and DNS is just one of them. So availability of the service when you are managing it yourself. Now, with cloud-based or public DNS, one of the main issue again tends to be it's also availability, but we know that those are usually big providers. They have multiple instances across the globe. That is usually the latency going through them. As we noted in the DNS Perf website, it's not as much of a problem nowadays as it was before. So it's actually a good thing. You have that option to use public DNS. But one other thing to consider is now you are separating DNS from your network. All the logs goes through another system, another provider, and what are the SLAs? What are the privacy agreements when it comes to storing those information? So things like privacy needs to be considered as well. Now, as I've said, there is getting more and more people are leaning towards cloud-based or public DNS, also because of trust issues. So with, say, governments in some economies, they would tend to have more control over service providers, get records or logs of those DNS queries. Usually, if you're using a third party, you kind of like avoid that, avoid surveillance, avoid filtering. So it can have that kind of like, it's a bit more free because they're not subject to local laws. But at the end of the day as well, if it's not subject to local laws, what are the privacy rules that they are subject to? It's like maybe a different country or a different economy. And what does that mean for your data? So things to consider. All right, so next is secure DNS transport, which was already touched on earlier. There's DOT, DOH, DOQ. I won't go through them anymore. But the one thing to think about here is if you are a DNS provider, you are providing DO53 at the moment, which is the traditional DNS over UDP or DNS over TCP via port 53. This is an unsecured transport, right? Everything is via plain text. So more and more providers are starting to look at also adding these features, DOT and DOH, as part of the options. So clients have the option to add security or add encryption in their DNS if they choose to do so. Now, the last one here, DOQ, is a very new technology. Well, it's been, the QUIC itself is still, it's relatively new, but it is standardized maybe 2-3 years ago. But DOQ have been standardized, I believe, just sometime late last year. It's being talked about for some time. It uses the QUIC protocol, which is has an advantage of being faster than TCP, and also provides DOT properties. So you have secure transport, but faster than your traditional DNS over 53. So again, more and more public DNS providers have support for these 3 transport types. With DOQ, not so much yet. If you go back quickly into this page where you have the public recursive DNS server, if you notice, you have columns. One is DNS over UDP. Obviously, all of them will have support for that. Next, you have DNSSEC, if they have support for DNSSEC validation. Again, most of them have this by now, except for a couple. I think this is like by design. So you have one that don't have it, but you have 2 or 3 others that does. And then this one, if you're doing DOT, DNS over TLS, DNS over HTTPS, and DNS over QUIC. So far, I'm not sure how updated this is, but from the last time I checked as well, which is late last year, only a couple of providers, or a couple of the known providers, big providers, are supporting DOQ because it's still new, and others are starting to trial and test it, but not available publicly yet. So if you're interested to try those out, I mean, you're not ready, your DNS provider probably is not ready, you can look at one of these public DNS operators and see whether you can implement DOT, DOH, or DOQ. All right. So this is kind of based on those things as well. So I'll just leave that out. And then the other add-on feature that I wanted to mention is filtering and DDoS protection. So again, more and more public DNS are providing support for this. Question is, if you are operating a DNS recursive server, would you, or how would you also implement something similar? Okay, so usually you would rely on a third-party threat intelligence that will feed information about the reputation of sites, okay, whether it's malware, then you block it. So basically, which ones are trusted and which ones aren't. So you can filter out and basically do not respond to queries for those sites or domains that have questionable reputation. All right. So showing you some of the public DNS servers here. Cloudflare DNS is one of them. So think about resiliency. Also think about DNS privacy options. One example of that is QNAME minimization. So most of the DNS software is already implementing this. So generally, no need for you to do anything, but it's always good to know what this does and whether, you can check whether your DNS software is actually implementing them. The idea here is to provide more DNS privacy. So generally, when you do a query, say, I don't know if I can run Wireshark because I was having a problem earlier. But if I can do that, maybe I can show you quickly. No, I can't, sorry. So you won't be able to use this one. But you can run it on your own setup at some point, maybe after this tutorial. And then try to see when you do a DNS query, what sort of information are you getting? It actually reveals quite a lot, especially if it's running over plain text. Okay, there are some PII or publicly available, like basically private information that is not supposed to be revealed, but because you have IP addresses in queries, you have the records in the queries, kind of like reveals a little bit more about you and your browsing habits. So with QNAME minimization, the idea is to limit the query that goes when you're doing the recursive query until it actually gets to the authoritative, because sometimes you need those information when you're talking to the authoritative server, but not so much to other DNS servers that will just delegate that query to another server because they're not the authorized server for that. So that's QNAME minimization. All right, so I think that's it for DNS resolvers. Just checking quickly if there are any questions when it comes to this. I hope it gives you a bit of an idea of, like,
any question, please?
Oh, there is, okay.
Yeah.
ဟိုကျွန်တော်တို့တွေတော်တော်များများ public IP ကိုသုံးကြတယ်ပေါ့နော်ဟို capability နဲ့ reliability ကိုကြည့်ပြီးတော့ကျွန်တော်သက်ဆိုင်ရာ ISP တွေရဲ့ DNS တွေပါတာမတုံးတင်တော့ဘူးလားတုံးရင်ရောဘာအတားချက်တွေရှိလဲ
မှာကိုရော public IP တကယ်လို့သုံးနေကြတာသုံးတာပေါ့နော်တေချာမကြားလဲရဘူးတစ်ချက်လောက်ပြန်ပြောလို့ရမလား public IP ကိုတန်းသိမ့်မကြည့် The voice was not clear. That they like sana public IP ကို public IP သုံးနေတယ်ဆိုတာကကြတော့ဘယ်ဟာမှာသုံးနေရလဲကိုယ့်ရဲ့ server တွေမှာဟလား DNS server လား
public provider တွေရဲ့ DNS ကိုမတုံးကြတော့တော်တော်များများမတုံးကြတော့ပေါ့နော်တကယ်လို့တုံးရင်ရောအတားချက်တွေရှိလဲ
The question is that now is most of the people are not the public DNS server. So mostly
ဟုတ်ကဲ့ဟုတ်ကဲ့
တို့8.8.8 တို့ဘာလို့ပဲသုံးကြတယ်ဒီ local DNS server ISP ရဲ့ DNS server တွေမသုံးတော့ဘဲနဲ့ဒီ public DNS server တွေပဲသုံးတယ်တကယ်လို့ public server သုံးနေဆိုရင်ဘာအားသာချက်ရှိလဲလို့မေးတာပါနော်
public don't know about other
Now most of the people are using the Google 8.8.8 DNS server 1.1.1 DNS server they don't use the local public ISP public server anymore what are the advantage and disadvantage of using the public server or the ISP public DNS server
Look, whichever DNS provider you use will definitely be up to you. But as I've said, you have to look at the pros and cons for each. There are pros and cons on running it yourself. There are pros and cons on depending on cloud providers such as Google, Cloudflare, etc. for your DNS needs. The main advantage I would say with running your own DNS server is twofold. One is obviously latency, because at the end of the day, no one can beat latency if it is in your network, right? So even though you have like really good benchmarks that shows the latency is very low on most of the public DNS, but if you are operating your DNS within your own network, then that's always the best one. Obviously, it's not good to just have one. You want it to be geographically or basically diverse as well. So usually you would have more that not just located on your own AS or your own network, but that's always the very first advantage. That is how traditionally it's done. You want it to be as close to the user or the client as possible. The other is the control. So if usually this advantage is from the point of view of the administrator. The DNS queries are, again, reveal quite a lot of information about users, which sites you're accessing, what services are available, that they are like people are using, etc. Usually you have some telemetry or graphing or information that gives the admins or the network operators some idea of what types of traffic are going through the network. It makes it easier to filter potential malicious sites because again you have control over that, and also the logs are stored locally. You are not relying on a third party which may have different rules legally with how this information are stored, particularly if it's not in your own economy. So very different laws with Myanmar compared to, say, the US. So things like that is something that is kind of like a worry. Now, what is the advantage of using cloud? With cloud DNS providers, they are mostly operated by very large, they're backed up by Google, by Cloudflare, and these are big operators. They run big networks, and so usually the availability is really good. There's always available. I think you've seen in the performance, usually it's almost 100%. Now, if you don't trust your ISP, which has become kind of like the norm in some economies, if they're doing, say, economy-wide filtering and things like that, then they tend to use public DNS providers because there's no surveillance, there's no filtering. You probably have seen stories in the news where, like some countries would block access to Facebook or social media, etc. So for those that are trying to circumvent that, they use publicly available DNS servers because usually they have, let's say, an economy or a government or some bad actors will have less control over public DNS providers. Again, it's pros and cons. There's a lot of advantages to both. Like in my case, if you notice, as I told you earlier, I'm using my own DNS server because at least all my queries are just within, all the logs are just within my machine. It doesn't even go elsewhere. It doesn't even go to my ISP or anywhere else. So that's a personal preference. And I think you should make that conscious decision, okay? Come within your companies, which one would be best for your case?
The Cloudflare DNS သုံးနေဆိုရင်တော့ဒီ government ဘက်ကနေ filtering လုပ်တာတွေပါတယ်မရှိတော့ဘူးပေါ့နော်ကိုတိုက်တယ်လို့သုံးလို့ရတယ်ဒါပေမဲ့ကို local DNS server ထားခဲ့တယ်ဆိုရင်တော့ကို local ထဲမှာကို cache တွေပါတယ်ကဒီကနေပဲ query လုပ်တယ်ဆိုတော့တခြား performance ကပိုကောင်းတယ်ကို personal cache ရဆိုဒါဆိုကိုယ့်ရဲ့ situation ပေါ်မှာမူတည်တယ်အစိုးရကနေမှ government legally Facebook ကို block လုပ်မယ် filtering တွေလုပ်ချင်တယ်ဆိုရင် DNS ကနေမှလုပ်လို့ရတယ်အဲ့ခါကျကိုက cloud public DNS server တွေသုံးလိုက်ဆိုရင်တော့ public DNS server တွေကအဲ့ဒါမျိုးတွေမရှိဘူးဒါပေမဲ့ကို company ရဲ့ကိုပိုင် own DNS server ရှိဆိုရင် caching facility ပိုကောင်းတော့ performance က better performance ဖြစ်တယ်အဲ့လိုမျိုးပွားသွားတယ်ဒါက based on the preference ပေါ်မှာမူတည်တယ်ပြောသွားတယ်ရှာပါမေးကြရှိသေးတယ်မသိဘူး
That was a very good question, by the way. But yes, there's no one right answer and there's no wrong answer. It really depends on your case and your situation. It's good to look at the pros and cons for each one. You know what's available and what are your options. Any other questions?
Sorry, because our sound is there. No question anymore, so you can
right.
proceed.
Awesome. Thank you very much. The next part I think is we can look at the virtual lab to give us some idea of how to configure DNS server. Some of you may have access and are able to log in to the APNIC Academy. If you can, then please open one of the virtual labs. There's a few there that is related to DNS, but at the moment we can focus on the DNS lab. So click on this link here in the virtual lab to open this page. It will load the lab for less than a minute. And when it's done, it will get onto a page that kind of looks like this with a few servers. I have here kind of like an emulation of DNS servers with the DNS hierarchy, starting from the root, the TLD, and then we have two authoritative servers, one primary and one secondary. This is not the actual root server. This is not the actual TLD server. It's kind of like an environment, a DNS environment on its own in this lab setup, so that we can see what needs to be changed at each step. When you configure your own, you would generally, of course, just configure a primary and secondary DNS if you're running an authoritative DNS server, if you are, say, hosting a zone. But if you're just running a recursive DNS, again, just one or two servers that is running the DNS application or DNS software, and it's functioning as a recursive DNS server. The good thing is most DNS applications and software that are available out there, let's say, for example, Bind, it has support for both or authoritative and recursive functions. By default, once you install it, it will act as a recursive DNS server. You have the option to change that if you only want the authoritative function, but again, by default, it will be a recursive DNS. So it's actually very, very simple to set up a recursive DNS server. Let me just, before going back into this lab, let me just show you quickly. This is the one that we are using in the lab. We are actually going to configure an older version, but the current stable release is 9.18.10. Okay, so this is the current stable release. It tells you when is the end of lifetime. For this one, it's 2026. So if you're starting to build a DNS server now, then you want to run the current stable version with support that is still like has a few years until its end of life, so you don't end up having to configure again or install a new one again. It won't be that difficult, but it just saves you, and you are sure that it has support. So this is again the current version. For the lab, it's still a bit older. I think it's 9.10. But the most of the configuration will be essentially the same. One other thing I want to show you quickly is which is Docker Hub, docker.com, which is this one. This is the one I used to set up on my own machine. This is a Docker container. You just need to do a Docker pull and then set this up. This is provided as is with no support, so it's a best effort basis as mentioned here. So you may need to make tweaks here and there if you install this. But if you do, it's very simple, right? It runs as a container. You just need to have Docker and then run it with these commands. And then as you have seen in my example, this is an example of an authoritative server running as a Docker container. So pretty simple to do that. Now, going back into this lab, in these servers, we already have DNS installed. So if I want to just double check that, I'll open one of the terminals. I'll open one terminal. So I can do sudo systemctl status bind 9, because this is an Ubuntu machine, and this is how you check if bind 9 is installed and running. So it gives you the current status. If it is running, you should see active running, but you also have options to stop the service or restart the service. So if I stop that and I check the status again, if you notice, this will show as inactive or dead. And if I want to run that again, I'll have to do start. So again, it's now active again. Now what the systemctl command does is run this service bind 9 that service. So if I open this quickly, more /lib systemd /system/system/bind9.service. If I open that up, it actually just executes user/sbean/named -f if you're starting it. And then it uses a utility called RNDC, or remote named controller, to reload or restart, or also to stop the service, whichever command you use. Now, basically the named command, this is the daemon that's running, that, you know, make sure that your DNS is active. So when it is active, named is running in the background as such. Now, how do I check which named version I have? You can use which named just to check where it's running. It's from. Right now, it's in /sbin. Named -v to show you the version. Again, this is a pretty old one with 9.10.3-p4, particularly for Ubuntu. But you can always install a more recent version. So let me go back to the instructions in this page. Now, the first part here for the recursive DNS is mainly just, again, verifying that your DNS server is running. That's essentially what we're already trying to do. And the next part is configuring this DNS server for the purposes of the lab. As I have said earlier, by default, once you install the service, it's actually going to be a recursive DNS server. Now, this part is mainly to make sure that it uses this topology that we have in the lab. It will use this local root server and this local TLD server. By default, when you run this, it will load named.ca. I think I should have that in /etc bind. If you notice here, if I open db.root, this is all the root servers, the 13 root servers are specified here. It's in your db.root, or what we normally call as the hints file. Why is it called hints? Mainly because it gives your DNS server an idea where to go next, right? Because again, when you query, you start with the root. How does your recursive DNS server know where to go? Where's the root server? What's the IP address of the root server? It is in the hints file. Now, most of the DNS application now would load the most recent version of the hints file. You don't really need to download a copy of this, but again, when it's installed, it also provides a local copy. You can always instantiate your configuration file to point to this named.root or db.root or named.ca. So the naming changes depends on the application and also the operating system. But at the end of the day, the contents are the same. That is this hints file with all the 13 root servers, okay, with the corresponding IP addresses on how to reach them. So that's your root server. Now, for the purposes of this lab, we're not going to use any of these root servers. If you see here, we've set up our own root server. So that's why we're going to configure in step 2. Now, just like backtracking a little bit, just make sure that we have done everything in step 1 to verify DNS. We've done these 2 commands, which named basically it just shows you the bind that is installed and the current version. We've done the status check. So we know how to start, to stop, to restart, and to check the status. And then just maybe checking where the configuration files are. So for Ubuntu, it is usually in /etc bind. So this is automatically created when you install the bind version or the bind daemon. And it will have these files already created. What are the important things here to note? We already talked about db.root, but you have other db files. So those are what we call as zone files. So if I open db.0, it has the base, which is for your local host. So it's pointing localhost as your NS. This is so for any local queries, it doesn't have to go outside of this DNS server. So because it's only locally valid anyway, so it will just resolve locally within this DNS server. So same thing with db.127 for 127.0.0.1. Now we also have db.local, which is for that local host again. If I open that up, so you have A records and quad A records for that maps for the local host domain. Now, what else do we have here? We have 3 named.conf files. We have a main named.conf. To be perfectly honest, for me, I tend to just use one named.conf, but they are separated here, so it's easy to see and it's easy to troubleshoot, and kind of like you have a separation where the different parts of your configuration file goes. So usually the default zone, if you open named.conf.default zones, it will have all the default zones for localhost, for reverse DNS for 127 and 0 and 255. So generally, if you are an authoritative DNS and you are managing a zone, you're authoritative for a zone, you will create a zone statement. So this is a zone statement. This is one zone. At the moment, this is only just for localhost. So even if you're just a recursive DNS server, usually you have this configured again automatically once it's installed, so you don't really need to do anything. But just so you know, it's basically you're creating multiple zone statements for the zones that you're authoritative for. Now we can also open named.conf.local. At the moment, I don't think there is anything there. If you have any local configuration, you can add here. And the last one is named.conf.options, which has some of the configurations that I've done. You have an options statement here. And then you have logging that's configured. You can add more configuration in here. Now, what are the important things to note in the option statement? Usually, that's where you specify the working directory, okay? And then if you are using keys for DNSSEC or TSIG or others, then it will have a key directory, so it will only use, you only like dump all the keys within the key directory and refer to that. And then if you want to filter, you know, who are allowed to transfer, usually the transfer happen only between the primary and secondary. So that's why you have this limit. 192.168.2.53 is the secondary DNS. So I'm only allowing my secondary DNS to pull the zone file from the primary DNS. Allows recursion currently is set to any, but you can limit that. You can add an ACL. So this part here can contain an inclusive term that's understandable by DNS, like any or all, etc. But it can also be specific IP addresses, like the ones we have here, or a list of ACLs. You can specify ACL and then ACL list name. You can add multiple IP addresses as part of that ACL, or maybe a range of IP addresses as part of that ACL, and then you add the ACL name within here instead of the word any. So this one is for allow query. Again, if you're running a recursive DNS, you want to limit that to only your customers, your clients, or your staff. So you only allow query for specific IP addresses and not make it available publicly over the internet. Okay. So hopefully that one is clear. You can actually have a lot more added in the option statement, or more generally in the configuration file. What I tend to do if I'm installing a new one and if I want to check all the possible options is go to bind9.read the, okay, I don't have it in my my cache anymore, so maybe I'll use this link here. So bind 9.read the docs for the current version. So this is the ARM or Administrator Reference Manual. So you can see all the configuration, all the options that you can use for specific purposes. So I suggest that you use this as a reference if you are going to set up your DNS. All right, so that's up to this part. And the other is for logging. Now, when you just configure this and you only have the default, usually everything goes into syslog. So I can do tail -f var log syslog, or in some cases that's var log messages, right? So remember that var log syslog. If you notice, I actually have a few logs referring to the DNS in here, but notice that we have already created a different channel to contain information or logs from DNS, and that is going to this file, var log named bind.log. So I'll close that one. If I do ls var logs named, inside there you have bind.log, this file. I can do a tail -f var log named bind.log, and that will usually have more information, and I can have more or less based on the categories that I want to define. So I have a few categories here, all the queries, all the default log files, all the errors, anything related to DNSSEC, anything related to transfers in and out, anything related to security. I channel that into named log, which all goes into the same file. If I want, I can have multiple channels. If I want to separate them, say for a busy DNS server, you're receiving hundreds of thousands of queries every second. And so if everything is in one file, it tends to be difficult to do troubleshooting. So you can separate them based on these different categories. You can have multiple log files. At the moment, as I've said, we're only using one, which is this bind.log file. What I can do is usually when I'm troubleshooting, I leave this running like what we did here. It's in a different tab. So when I do changes in my named.conf and then I restart, sudo systemctl restart bind 9, right? So it will restart. Again, I usually check the status just to make sure that it is running. I can also do check the processes, psax or psaux rep named. You'll notice that named is running here. So this is the process that is running named in the foreground with user bind. So once I restarted that and I go back here, it actually shows me a bit more information on like the recent reset. So notice here, all zones loaded. That's what you're always after. All zones loaded and running. If there is any error, you should be able to see that very easily from here. That's why it's always good to have that running in the background or in another tab when you are troubleshooting. All right, so that's that part. Now, it says here that you can check with the other servers just to check that they are running. Probably won't do that here in the interest of time, but assume that they are not now running. But when we go to them, to these servers, we can always still check that using this command. All right, so the next part here is to configure this primary DNS so that it will use a local hints file pointing to this local root server. Okay, now I'll go back to the primary DNS because that's where we need to configure that. So I'll generally I'll get that from the internet, but since we are running a local root server, I will have this one. This is optional obviously, so I will go to this part. All right, so I'm in the correct path in /etc bind. I'll create the hints file. So sudo, maybe I'll just do, just so make this easier for me and faster, I just change to root. but you can always use sudo. Okay, so vi lab, we call it lab-root.hints. And then we'll add a link to dot, and then set a very high number for TTL, because root servers, the records for root servers don't tend to change very often. So you can add a very high TTL. If you are having records that tends to change more, then the typical TTL size or value is 1 day or 86,400 seconds. And this is a record 192.168.100.250, which is the IP address of our oopsie. Let's go back to it's this one. Just be the same. There you go. And then close that. And then here, I'm going to then open my named.conf, named.conf.options. And then I can add, maybe change this directory. Usually, since it's the cache, you also have the option not to change that. But since we're adding a lot more files into our folder, so I'm going to change this to /etc/bind so they can easily see it. So there are multiple ways to comment out in bind. You can either use this double slash or a quotes, not quotes, but hash. So this ones are all comments, like these ones on top. So they're commented out because we don't need it. All right, so next I'll open named.conf.local, local, and then add a zone. This is the local zone that we are configuring. Type hint file /etc/bind lab-root.hints, which is the file that we just created earlier. And then we can, you need a, this one, we just open named.conf the default zones to check that we have all the local zones set. So we will need the zone localhost, which is there. Okay, that's good. And then here we can do restart bind 9, or we can use RNDC to restart. So right now it did restart, so no issues. Just check the status to be sure. There you go. So it's active and running. And then I can usually, again, this is default zone, so you already have that, but you have options to update this if you need to. At the moment, we already have all of this configured, and then we've restarted. So now I should be running a recursive DNS server. So dig at localhost x@root-server.net, because we have this, we have the root and GTLD, so this one should resolve. There you go. We are able to do a recursive query. So we queried 127.0.0.1, which is this machine, okay, for the IP address of x.root-server.net. I think I should be able to do plus trace here as well, which is like so. So if you notice here, it did the query from the root, which is this dot, and then the GTLD, which is this, sorry, this is the root server that's authoritative for that. If I do GTLD server, then it should trace from root to TLD. So this is root up here, and then .net, because that's a TLD, and then GTLD server.net. So it gave me that answer. All right. So at this point, we have a fully functioning recursive DNS server for the purposes of this lab. Now, it did look a bit more complicated because again, we're using a root server for this lab. But as I've said, if you're going to set up a recursive DNS server locally in your machine, on your own environments, it's as simple as installing the DNS application. Usually you can use the package manager on your operating system to install it, or you can install from source, or as we shown earlier, just download an image or a container, install it as a container, and that's it. So pretty simple, but then make sure that you read the documentation so that you have an idea of what information or what changes can you make on your named.conf, your configuration file, to add more features, to enable or disable features, or to add security. As I said, you don't want to be running an open resolver. So please make sure that you have limited who will have access to it after you've set it up. The next part here is the authoritative DNS in part 2. So we will configure both the primary and secondary DNS server. Starting off with the primary, we're already in the primary DNS. Notice that this is the primary DNS. We're still in etc bind folder. What we'll do is create another folder called master. Oh, looks like it's already there. So we don't need to create it. We'll just need to get into that folder. At the moment, there is nothing in there. So I'm going to create a zone file. Two important things. When you're authoritative for a zone, in this example, I am using myzone.net. I am authoritative for my zone. This primary and secondary DNS are my authoritative DNS servers. I need to configure two main things. One is create the zone file because they will contain the resource records, the mapping, the actual mapping from IP to domain to IP, etc. And then we need to update the configuration file named.conf to add the zone. All right, so it will be like this. All right, so let me maybe create this vi db.myzone.net. And then usually for this lab, what I tend to do is base it off from a previous, let's say db.local, like this one. And then I'll just name it db.myzone.net. Obviously, you can create it from scratch, but it just makes it a bit easier. And then I'll change some of the values. Again, typical TTL is 1 day, so I'll change this to 86400, or 1D is also acceptable. I'll change all the local host to myzone.net. Everything. Oopsie. Oh, 2 dots. There you go. This one should be the name server, so it should be ns.myzone.net. And then usually this one should be your IP address. 192, are we using 192.168.1.53. And you can add more records into this. Just to keep it simple, I'll keep it like this for now. One quick thing to remember, whenever you make changes in your zone file, maybe you're updating a record or adding new records or removing records, make sure to update this serial. The reason for this is because you would normally, when it does a transfer from the primary or secondary, the secondary DNS will check the primary for these records. Just one quick second. Pyo, can you take over for a little bit? I just need to grab something.
Okay, so I take over your lab, right?
Yes, or if there were questions, just for a couple of minutes. Sorry about that.
Okay, I am answering the questions. You want me to take over your server?
You can if you want. Do you
Oh.
have access?
Yeah,
If not, just explain, but just I'll be back quickly.
okay, okay. So now you are at the step of, please let me take over you. Wait. I am stuck in somewhere for a while. Okay. Currently, Shane is doing the root primary, which step she arrived. Now there are few resource record. She is doing the adding the domain name NS1 a record 192.1 that we need to copy and paste. Take control. Okay. Now she is showing the configure the step 1 we are going to do according to this lab DNS 001 lab. Aku part 2 ကိုရောက်သွားပြီ part 2 မှာဆိုရင် step 1 က configure the primary DNS server ဆိုပြီး primary DNS server ကို configure လုပ်မယ်အခုဒီ primary DNS server လုပ်မယ်ဆို primary DNS server တွေကိုဝင်လိုက်တယ်ဝင်လိုက်ပြီးတဲ့အခါကျတော့အခုပဲရောက်နေလဲဆိုတော့ तू က ETC တဲ့က bind တဲ့က master တွေကိုဝင်တယ်ပြီးရင် master ဆိုတဲ့ folder တစ်ခုအသစ်ဆောက်တယ်အသစ်ဆောက်ပြီးတဲ့အခါကျတော့think a domain name. Oh, no. Screen. I need to share the screen.
Sorry, I'm back. It's okay. I can take over.
Okay, so because I cannot share the.
Sorry about that.
Yeah.
Okay. Sorry for that. I had to just grab something very quickly. Okay, so we left off in here.
So I will control now.
Yep.
Okay.
Were there any questions earlier that we need to answer?
Okay, so I think yes. I already answered.
All right, awesome. Thank you, Pio. Okay, so going back here, so you can configure your zone file. Right now, it's very simple. We have the TTL at the top. You have the SOA record or the start of authority. I think we haven't updated the serial yet. Serial is essentially just incrementing. But typically, we, as a common practice, we use the current date. So 2023-01, what's the date today? 14 and then 01. So it's a 10-digit character. Okay, so you can use that. And then whenever you make changes, let's say for the same day, I change it again, so it will be 2 or basically incrementing up to 10. And if you change the dates, maybe tomorrow, it will be 1-5. So the reason for that is because if you're, using date, there is no possibility that they will go back to the date. So it's always going to be going up. And so with that, your secondary will always check the serial number of the primary DNS and then fetch the updated version of the zone file if it's different, if it's higher. But if you don't change it or you set it to a lower number, then it won't be able to pull the most updated version of your zone file. So just bear in mind to always update the serial number in your zone file. Now here you can add more records. Right now we have one NS record. As I've said, it's always good to have more than one name server. So if you do, you will have two records here, maybe that NS, and then you have an ns2.myzone.net, right? And then you can add an A record for your, say this is NS. And then if you want to have for NS2, maybe pointing to the secondary for now, like that. So you can do that. You can add multiple A records, MX records, etc., like the ones you have here. Okay, mail servers, etc., are also there. Just make sure that you have, say, for mail server, say myzone.net, that will be MX 10 mail 01, and then MX, another MX 20 mail 02. So what's the difference here? You have two names, two mail servers, mail 01 and mail 02, and this one is priority. The lower number is more priority. So whenever I'm trying to send an email and it does a query for the MX record, it will give mail 01 first, and then it will try. And if it doesn't work, you know, go back and then get the second one to send the email. Now, if you notice, in some cases, I have a trailing dot, which is this one here. If you do have a trailing dot, then let's say this domain, it will be like that. Remember, if you're going the hierarchy, the DNS tree, the top of the hierarchy is the dot, which is the root. So if you have this, that's basically your FQDN, or fully qualified domain name. So that's ns.myzone.net dot. If I don't have a dot, a trailing dot at the end, like say, for example, here, it will append the name of my zone file, or the zone name, or whatever you configure in the zone statement, right? So in this case, this is equivalent to typing out mail01.myzone.net dot. So kind of like a shortcut. If you don't want to add a trailing dot, you know, if you don't want to specify the FQDN, don't add a trailing dot, and it will append the zone name into it. Just make sure that if you have, say, a fully qualified domain name already, don't do this. Because if you don't have a trailing dot, this will be mail01.myzone.net.myzone.net. It's because, again, it will append that, the zone name. So add a trailing dot, or remove all of this altogether. Now, because here we specified mail 01, we need to have an A record for mail 01, right? So in for internet, and then A record. Let's just assume this is 192.168.1.201, and then mail 02 is 192.168.1.202. Obviously, we don't have that server. We're making some assumptions on what servers we have on the network. So you can add more information here if you need to. But that's basically what we want there. We have a database, database file, or the zone file. And now we will update /etc. I'll get out of here. We will update namely.conf.local. And then we will add the zone statement similar to this one, but that one is type hint. But we will have myzone.net, which is a type master. So for primary, it will be type master. Because we set it up in the primary DNS, it is type master. If we set it up in the secondary, it will be type slave. So we know the functions of each. So the master or the primary, all the changes will be added there. And then the secondary will pull the latest copy from the master. And then specify the file, which is /etc bind masterdb.myzone.net. Now you don't always have to specify the full link here. I did it that way because it's a bit simpler and avoids mistakes for people doing this. But since you're already in /etc bind and your directory is /etc bind, you can remove this part up to here, all right? and then just add master. So like a relative path instead of an absolute path. But here we use this absolute. All right, so we have updated two things. We've created the zone file inside master, this one, the myzone.net DB. And then we've updated named.conf to add the zone statement, right? So this is the zone statement. And so with that, we can now restart sudo, or maybe in this case, we don't need to, sudo systemctl restart or stop start, bind 9. Again, check the status. And then see whether it is running. Notice here, you have zone myzone.net. This is the serial, which is the serial that we created today. All zones loaded and it's running. So meaning you now have a running authoritative DNS for myzone.net. Now we have here as well sending notifies. We said earlier that your master or primary can send notification to the secondary to specify, that we have this zone file, it's changed or it's new, and then it will send that to the secondary. At the moment, it won't be received by the secondary yet because we haven't configured it, but at least your primary DNS server is working. So if I do a dig at localhost, ns.myzone.net, I think this should work. There you go. I have an answer. It's an A record. We have a corresponding authority, which are the two name servers that we specified at the top after the SOA record. And then just additional information here for the other name server. So we should be able to have all of that. All right, so I think that's it. That should be working now up to this stage. I guess just very quickly, I'll configure the secondary DNS. Open up secondary DNS here, open the terminal. Let's just do sudo su for simplicity here. You don't always have to do that. And then /etc bind. Notice I have a slave folder. Okay, the zone file from the master will be copied over to the slave, but I don't need to create the zone file. What I need to do is open named.conf.local and then configure the zone statement for myzone.net. Okay, and then here it's now type slave because this is secondary. Specify a file. It doesn't always have to be the exact same name and path as the one you have in the primary, but for simplicity and also for consistency, it's always easier. We'll just add the same name. I may need to extend this lab. There you go. And then what's new here is we need to specify the IP address of the master. So we'll have masters, and then IP address 192.168.153, which is the IP address of the master. There you go. And then closed it up. This is the syntax for configuring your named.conf. And then I would probably, oh yeah, we need to add a hints file because we haven't configured recursive for this one. So let me just open named.local again, then add zone dot, type hint, file /etc bind lab-root.hints. There you go. Oopsie, oops. Oh, and then close it up. And then I'll have to create the lab root hints. 86. And as x dot, let's make that x dot root-server.net. Doesn't have to be caps. It's just like how it usually is with root configuration. So usually it's better to do the same. 86 and a lot of zeros, a record, and then 192.168 at 100 at 250. All right, so we have that. Let me just fix, oopsie. fix the logo. All right, so I should be able to restart bind9. Hopefully it does work. Hopefully I didn't miss any syntax. Check the status. Oopsie. Typing too fast. So, oops, it failed. All right, unknown class type. So you should see the error here. I'm going to open a new tab so we can check that as well easier. Sudo tail-f var log name the bind.log. Okay, maybe let me try to restart here. So the, oh, sorry. Restart there. So we see again, what was the problem? Oh, it didn't show. Oh, because it's not. It's already stopped, so I can't restart. So it should be start. So it will try to start. It didn't, so it doesn't see any error. All right, /etc bind. I think it's a problem with hints file. It's not the same. Add way too many zeros, or I can add more zeros here. There you go. Let's try if that one works. Status. Still the same. Can someone tell me? This is part of the fun, right? You'll need to know how to troubleshoot. Unknown RR type. Okay, what did I miss there? Oh. I don't see a problem at the moment. Should be correct. Usually it's the tabbing that usually has an impact. I don't know if this is the work. Let's try again. Same. All right, what I'm going to do is copy from the other one. Might be a bit easier for us rather than trying it out. What's the IP? 192.168. 2.53. Go back here quickly. Host. Okay, so /home/host. So I need to copy that over. Permission denied. There you go. All right, let's try this copy and see how it is. /etc bind. Is it different? It looks exactly the same. Let's try. Yep, it should be this one, right? All right. So let's just see this again. Systemctl restart bind9. Status bind9. Okay, now it's running, active and it's running. And this is the secondary. I'll keep that running. Var log named bind.log. So I have that in the background, but you can see here now, you see a transfer happening. Transfer started. We didn't create the zone file, right? If you remember here, slave folder was empty previously. Now you have db.myzone.net. You won't be able to open this though. It will be like this character. So it's already compiled version of the zone file that you created in the primary. Now this used to be text file when it's copied, but with the recent versions, actually not so recent, but it's been a while ago, they changed it from text file to now a compiled version. So you won't be able to open this file, but you know that this is the same zone file. And if I do dig at localhost for ns.myzone.net, I should be able to get an answer. Again, you have two authoritative DNS server, including this server. So I think that's mostly it that we wanted to show you. We've managed to do all of that. The zone transfer did happen, and it's this part here. Okay. One other thing that you can do is dig at, so this is the secondary, dig at the primary 192.168.1.53, and then AXFR. myzone.net, and then AXFR, and there you go. You're able to copy the entire contents of the zone file just using a dig command to the primary. Now, because the primary, we only allowed the secondary, so you're able to do that, but other DNS servers should not be able to do zone transfer. That's one of the things to remember. That's why you want to limit who can do transfers, because otherwise anyone, any machine can have a copy of your zone file. Getting one record is okay, but getting a copy of your entire zone file gives a lot of information about your network, right? About the services that are running on your network. So it's not good if it falls in the wrong hands. Okay, so I think that's all there is in the lab. There's a few more here, but we won't have time to do that. Hopefully, when you get a chance, you'll also try to do reverse DNS. Okay, I have in here some slides for reverse DNS. Forward DNS is essentially what we already covered in some presentation in the lab, but I would encourage you to open this presentation on reverse DNS and have a read through that. And if you have questions at some point, and if you have IP addresses and you create reverse DNS or reverse zones for that, and you're having trouble configuring them, please reach out to either myself or to Pio. But yeah, I will have to leave that part for you guys to do by yourself. That's part 3. And the part 4 to add a bit more security. So you have secure zone transfer and RNDC. The good thing is, actually, as I've said earlier, you already have RNDC. Okay, this is already configured here. Some of you may have noticed you have RNDC.key, and that has a key installed like already in this folder, so it can run RNDC. What is RNDC? It's remote named the controller. So if I open man page, you have here RNDC. It's a name server control utility. What it does is avoids us, well, two things, obviously. One is it avoids us from having to always restart the service every time that you make changes. It's not good. If you're running production network, production service, then you don't want to restart the service every time. If you have big zone files, it will take time to load them. So better that you run RNDC to just reload the config, do a lot of like commands, reconfigure, etc., but not restart, kind of like turning it off and turning back on again, which takes a lot longer. The other is RNDC is remote, named the controller. So meaning you can run this command either on this machine or maybe a different machine. I tend to have RNDC in my local machine so that I can control my remote DNS servers. All right, so I think that's all the time that we have in this tutorial. Please do let us know if there are any further questions before we close. Pio, do you have anything to add? Oops, you're on mute.
Please help to fill up the survey form.
Oh, yes, yes. If you can take a few minutes now, there is a
Yeah.
survey link in the wiki. Pio, I think, has also posted it on the chat somewhere. Please fill up the survey for us. That will be very helpful.
Take some time to survey.
And then
And-
if you have further questions, if you want some help, Pio is a community trainer, and she obviously speaks the local language. So if you need some technical assistance, I'd be happy to help you guys out.
You can reach me, and then community trainer email also we can share to them, right?
Oh, yes, there is a community trainers at apnic.net.
Yes, you can email to this email also. Community trainer at apnic.net. Yes,
Trainers.
yes. You
All
can,
right.
then maybe you can chat to me privately also, okay? Anything. Then
Thank
we are happy to assist, and anything you can ask me freely. Thank you very much for your time and attendance. Thanks, Jane.
Thank you as well. Thank you, MMNOG team, for giving us an opportunity to do this tutorial for the community.